All right, adding and subtracting rational equations. What you need to do with this is find a common denominator. So I use a method called crisscross straight across. So straight across on the bottom, 3 times 2k squared plus 2k. Okay, that's going to be our denominator. That's the straight across piece. Now the crisscross piece. This goes up there. This goes over there. 5k, 2k squared plus 2k. And then 3 times 5k plus 2. Okay, now we just need to simplify. Your bottom's going to stay exactly the same. All right, so we're still going to have that on the bottom. On the top, multiply this out, so you get 10k cubed plus 10k squared. Over here, we'll have 15k plus 6. All right, so since this is adding, we can just rewrite it down here. So we get 10k cubed plus 10k squared plus 15k plus 6. Combine like terms, but there's no like terms to combine. So in this problem, which is pretty rough, this is going to be your final answer there. Okay. Number 32 is very, very similar. However, it's going to be a lot easier due to the denominators being easier. Crisscross straight across. So we'll do our straight across piece. M minus 2. M plus 1 will be my denominator. And then the crisscross. This goes up there. This goes over here. 5 m plus 1. 6m m minus 2. All right, so we already have our denominator. This is 5m plus 5 on top. Distribute 6m squared minus 12m. There's my denominator. Write this out. 5m plus 5. This is a plus, so everything stays the same. Remember, if it was a minus, you would need to distribute the negative. Combine like terms. We actually do have a couple of like terms right here. So the denominator stays the same. 6m squared. 5m doesn't have anything, so it stays the same. 5 and negative 12 make negative 7. So that's going to be your final answer on number 32. 33. 33 is a multiplying problem, which means we need to simplify the top, simplify the bottom, and then we can work with it. Remember, anything with 2 terms, factor out GCF. Anything with 3 terms, factor out GCF, but then you're end up going to have to play X games to do this. Well, this is 2 terms, so we need to factor out a GCF. So what goes into 21 and 24? That's a 3. Then what goes into b and b squared? Take the smaller, so that's just a b. So that leaves me with 8b minus, or actually just, sorry, 8 minus 7b. Down here at the bottom, 2 terms again, factor out what they have in common. So that's a 7. So it leaves me with 7b minus 8. Now, over here on the other side, nothing really cancels, or nothing simplifies. So right here, you see that these two are opposites. So the way that we can fix that is by factoring out a negative 1 on top. So we're going to make this negative 3b, and that makes that 7b minus 8. 7 times 7b minus 8. 1 over b minus 2. Now we cancel out what they have in common. Those cancel. That's actually the only thing that we have in common on this problem. So negative 3b times 1 is just negative 3b. On bottom we have 7 times b minus 2. And that would be your solution. 34. Two terms, we factor out GCF. 3 terms, we do X games. This is a 3 term. So we need to find something that multiplies to give negative 35 and adds to give positive 2. Well, that's going to be positive 7 and negative 5. So we can factor this to n plus 7, n minus 5. 2 stays on bottom, nothing we can do there. N plus 7 stays on bottom, nothing we can do there. Cancel out what they have in common. That ends up being that. So my solution, n minus 5 over 2. All right. Pretty simple and straightforward. On number 35, the difference here, this is division. So with division, we do keep, change, flip. Keep, change, flip. So we keep the first fraction. Times flip the second fraction. Okay. Now we need to factor this, but there's a -1 out in front that we need to deal with first. So I'm going to factor a -1 out and make this m squared minus 12m plus 35. Okay, you never want to do factoring if there's a negative out in front. So with this problem, we're looking to something that gives 35, adds to give -12. Sorry. All right, so that's -7, -5. So I factored this, -1's out in front, m minus 7, m minus 5. On bottom there's a 3, 3, m minus 5. Cancel out what they have in common. M minus 5s, 3s, and that's what's left. So we have -1 times m minus 7. If you want to distribute that out, you could put it as -m plus 7. Up to you, and it's kind of up to what the multiple choice question, the answer looks like. Okay? 36 is another division problem, so we need to do keep, change, flip again. Change the sign, flip the fraction. Notice I do that before I do anything else. Now, 2 terms, factor out GCF. 3 terms, do X games. So none of this over here simplifies. 4 and 8, factor out of 4, so that's X minus 2. X plus 5 doesn't simplify. Cancel out what they have in common, so that's the X minus 2's. So we're left with 4 over X plus 5. That's our answer. All right, on 37, they ask us to simplify it and state the excluded values. So to simplify this, we need to figure out what goes into 16, 20, and 36. Also, they all have a b in common, so we can simplify that as well. So on top, if we divide everything by 4b, since that's what they have in common, this turns into a 4 over 20 divided by 4 is 5. B squared divided by b is just b. -36 divided by 4, -9, and the b's cancel. So this is the simplified version. Now, as far as excluded values, that means denominator equals 0. Add the 9, divide by the 5, b equals 9/5. Now, remember, with this right here, since that's what they have in common, that's actually going to end up being a hole in the graph. But if we're looking at it from the beginning, that means, hey, what else could be excluded? So you might also have b equals 0 as an excluded value. So be careful for that. Watch out for that. That might be an excluded value, but 9 over 5 is definitely an excluded value. Something that cannot be. The denominator equals 0. 38. Again, look at it, see what they all have in common. They're all divisible by 8. So that makes this 7x plus 2 over 7. All right. Then state the excluded values. Well, denominator equals 0. 7 equals 0. 7 doesn't equal 0. So there's no excluded values. This is the simplified version. Absolutely no excluded values on this problem. All right, that'll be the end of this video. I'll pick up with number 39 in the next one.